So hi everyone, today we'll be doing an example session on current, electricity and magnetism. Current electricity is an extensive or a difficult difficult topic, but if you can understand all of it, it won't be much of a problem. Alright. Now magnetism. We all know that through electricity we can generate magnetism, through magnetism we can generate electricity. Alright. Now let's go into the question so that we can understand it better. Which of the following subatomic particles carries an electric charge? What do I mean by subatomic? Alright, if you remember in the lectures, I told you that there are protons, electrons, neutrons. Okay, and I also remember telling you that this is at the smallest level, at even after atoms. Alright, so atoms constitute all this. Okay, so you can't even see these, but they are very small, and these contain charges: positive, negative, neutral. Okay, neutral means no charge. So subatomic particles that carries an electric charge: proton, neutron, electron, photon. Photon is comprising light. All right, electron, electric charge, electron. Okay, which of the following is a good conductor of electricity? What constitutes a good conductor of electricity? Which lets the flow of electrons. Electrons move, and they move freely. Alright, they move freely. So a good conductor lets electrons flow freely, and so here it is copper. Remember copper wires? 1, 2, 3. These are wires. This is plastic or rubber. Copper wires. Which of the following is an insulator? What is an insulator? No flow of electrons. It obstructs, resists flow of electrons. Plastic. Plastic does not let electrons flow freely. Alright, so always remember this. Aluminium, it is a metal, it will of course allow. Silver, yeah. Iron, yeah. But at which extent, that will depend upon their resistances. What are resistances? How much resistance would it provide to these flow of electrons? Alright, the unit of resistance is also this. Okay, this is ohm. Like Jadoo says, right? Ohm, this ohm, OHM. Alright, ohm. Electric current is measured in what? Alright, electric current is measured in amperes. Alright, amperes. What do we use to find out how much current? Ammeter. Alright, ammeter. And unit is A. Amps. A. Okay, so amperes. SI unit of electric power. What was electric power? If you remember, P is equal to V into I. Okay, volts into ampere. Power is watt. It's watt. It is also joules. Alright, joules per second. How much energy are you consuming? Okay, joules per second, J per S. So watt. Unit kilowatt hour is used to measure what? Kilowatt hour is commercial unit. What do I mean by commercial unit? For money purposes, to put prices, alright, commercial, to sell, alright. If I sell power, at what unit will I sell it so that I can put a price to it? That is all commercial. SI unit, standard unit is what? Okay, standard international. Alright, the unit kilowatt hour is used to measure what? Electric power. kWh. Okay, now we come to this. Examples. The heating effect of current is made use of an electric heating effect. If you remember the heat formula, CIT. Okay, current, time duration, and all. CIT, if you go back to the lectures, you will be able to see this formula. Okay, now electric fans, electric lamps, electric heaters. In your press, electric iron, okay, and electric heaters, nichrome wires, geysers in during cold months, geysers, all these use heating effect of electric current. You switch it on and current flows, it heats, right? Why is there an heating production? Flow of electrons. Every material will resist electrons. Conductors also resist, but at a lower level. Now heating things are always made of alloys. Okay, what are alloys? They're a mixture of elements, mixture of metals, elements and all. Okay, now these offer more resistance, and since there is resistance, there is friction, there is heat produced between the electrons, and it heats up. Which of the following effects of electric current is used in electroplating? Now what is electroplating, if you remember? Okay, this was a solution of the metal to be the solution of the metal to be put inside the solution of the metal, all right, that we have to put over here. Supposedly this was copper, Cu, and this was some other metal. I want this copper over here, so this copper will first get dissolved into this solution and it will get electroplated over here. This is a battery, positive, negative. I connect the metal that I want to go to the positive end, and metal that is to be electroplated to the negative end. Okay, negative. So what type of what effect of electric current is this? Chemical effect. Which of the following is an example of a primary cell? Now primary cell, secondary cell, what was the difference? Primary cell, they die out, all right, they cannot be recharged, you have to throw them away. Okay, now on the other hand, secondary cells you can recharge. All right, what is an example of a primary cell? Alkaline battery. What is a lead acid battery, solar battery, lithium ion battery? They can be recharged. Okay, now solar batteries, they convert sunlight into what? They convert sunlight into electrical energy. You see solar panels, they are blue in color, right? They are blue in color. Sun rays fall on it, it heats up. This is very hot, by the way. Okay, and during the day it will take all the energy, it will convert it, and at night you can have that electrical energy, or even during the day you can use it to. There are solar geysers, solar cookers. Nowadays people have solar panels over their houses and they are using it to produce electricity because it is a sustainable way. Sustainable, it is an environment friendly way, all right, it is friendly to the environment, it is not causing any pollution. You are utilizing the sun rays that fall on empty or useless places, all right. Which device is used to measure electric current in a circuit? All right, which device is used to measure electric current? Ammeter. If it was not written measure, if it was written detect, then what would be the answer? Then this would be the answer. Okay, if it was written something else like what can step up or step down, voltage, current, whatever, then it would be transformer. Which device is used to measure electrical potential difference? What is potential difference? Like I told you, here there are charges, here there are no charges. These will try to flow over here. Okay, it's a potential difference. This is voltage. Okay, how much potential difference is there? Okay, so this is voltmeter, as the name suggests. A device that converts electrical energy into mechanical energy is called what? Okay, electrical to mechanical, it's a motor. Okay, if you remember a fan. Okay, a fan is somewhat like this, if I'm not wrong. Switch on, you see it rotates. Alright, see this arrow, it is rotating in this direction. Rotating, 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 rotating. How does this happen? There is a motor over here. Motor. Okay. As soon as I turn it on, it will convert your electrical energy, and it is connected to a rotator. Alright, it is a rotator, and this will keep rotating. You put anything over here, it will also rotate. So this fan that you see is connected to a motor and it is rotating, so the fan is also rotating. Which type of dynamo generates alternating current? AC dynamo. Why AC? AC is alternating current, DC is direct current. Alright, if you remember, I have told you the difference between these two in the lecture as well. Why AC? Because we can connect multiple appliances to AC. Alright, direct current, it is only flowing in one direction. Alright, so AC dynamo, it generates alternating current. Which of the following is not a property of magnets? Alright, so magnets can attract something, magnets can repel something, magnets can produce electricity, magnets can and electricity can produce magnetism. Alright, so what is a property of magnets? Attracting iron, creating a magnetic field, conducting electricity, repelling other magnets. As I said, repelling it can do, creating a magnetic field it can create, attracting iron, yes, conducting electricity, no, it can't conduct electricity. Magnets are not conductors. Okay, magnets are not conductors, of course. The region around a magnet where its magnetic influence can be detected is called what? Magnetic influence can be detected. It's called what? Magnetic field, magnetic pole, magnetic flux, magnetic domain, what? So if you remember, I have told you, supposedly this is a bar magnet, north and south. Okay, I will even cover this south. Okay, north and south. Okay, there's a difference in color. Field lines will originate from here to here, and these are in the form of concentric circles. What? Concentric circles means they are originating from the same place and it's circular in nature. Okay, and these travel from north to south. North to south, they are going in this direction, this direction. There are no field lines inside. All right, this is a magnetic field. Okay, a magnetic field. What happens when a current carrying wire is coiled around an iron core? Current carrying wire. This is a circuit. This is a iron core, an iron nail. This wire is wound up around this core, positive, negative. Current is flowing from positive to negative. Okay, what happens? Okay, if it is around a soft iron core, it will attract pieces of metal, okay, towards itself. It becomes an insulator. It loses magnetic properties. No, whenever we pass electricity to a soft iron core, a magnetic material, it can become an electromagnet. All right, so it becomes an insulator. It loses its magnetic properties, becomes an electromagnet. It generates electricity. It becomes an electromagnet. All right. Which of the following is not a way to increase the strength of an electromagnet? Okay, so the strength of this electromagnet can be increased how? Stronger current, okay, or more turns in coil. This is called a coil, okay. This winding up of wire, this is called coil. If I increase the number of turns, supposedly it was only two turns, okay, then no. If I increase it again and again and again and again and again, this will have more current flowing through it and more magnetisms, okay. So more turns in coil, stronger current. Now, and what, this material should be soft iron core, okay. So increasing the current flow, yes. Adding more turns, yes. Using a non-magnetic core, no. Increasing the number of coils, using a non-magnetic core won't help, it will not become an electromagnet. All right. Now, which of the following is an example of a natural magnet? What do you mean by natural magnet? Occurring in nature. We do not make it an electromagnet, it is already a magnet, okay. Bar magnet, electromagnet, permanent magnet, all electromagnet. How do we make permanent magnets? We make it permanent. All right. A bar magnet is a natural magnet. All right. Now, or even permanent magnets, all right, they are natural in nature. Okay, you can take both. Which type of magnet can be turned on and off using electric current? Permanent magnet, natural magnet, electromagnet, electromagnet. As soon as I turn off this current, okay, soon as I turn off this current off, current won't flow, this will lose all its magnetism, okay. So electromagnet. The phenomenon of electromagnetic induction was discovered by who? Now this is an important question, this might come. Michael Faraday. Michael Faraday was the one that discovered electromagnetic induction. What is electromagnetic induction? Producing electricity using magnets, magnets. If you remember, I showed you a diagram. There is north pole, this is south pole, there is a coil over here connected to rotators and current flows through these. All right. So you need not go into the details, but this was discovered by Michael Faraday. What? Electromagnetic induction. The device used to increase or decrease the voltage in an alternating current circuit is called what? You increase or decrease the voltage. It was done using primary coil, secondary coil. This is a transformer, not a transformer like the movie. No, this device is called a transformer. What does it do? It increases or decreases the potential difference, okay. I can increase a potential difference and also I can decrease a potential difference. Transformers are used in generating areas, all right, where there is production of electricity. They use transformers. It is an important device, all right. This was soft iron core, laminated soft iron core, the square that you see, all right. And this was a primary wire here, this was a secondary wire over here, and this is a transformer, okay. In an electric motor, electrical energy is converted into what? Mechanical energy. Motor means mechanical energy, okay. Which of the following is not an application of electromagnets? Magnetic levitation trains. Now see, have you seen a bullet train? That is a magnetic levitation train. It does not touch the track, okay? No, it slides or glides over it, okay. This glides over it. Since it is gliding, it is magnetic levitation. Electric bells, they use electromagnets. MRI machine they use. Solar panels they don't use. Okay, no magnets. Magnets, no. Which of the following materials is attracted to a magnet? Alright, which of the following materials is attracted to a magnet? Nickel, copper, aluminium, silver, what? Nickel. Right, nickels are attracted. Metals are in general attracted, but nickel. Okay. Magnetic field lines around a bar magnet. Remember this diagram? Originate from north and south, north pole and terminate at the south pole. This is actually the correct option. Originate from south and terminate at north. Like I told you, these go from this. Okay, north to south. Okay, not the other way around. Okay, they are not going in this direction. No, they're coming this way. Okay, so they form closed loops inside the magnet. There are no loops. Okay, this is only N and S, no loops. They do not exist. Of course they do exist. Strength of an electromagnet depends on, like I told you, all of these. Go through the options, all of these. Which of the following is a characteristic of a series circuit? Now this is an important concept. Alright, what is a series circuit? I will teach you. When multiple appliances are connected in single wire, one after the other, okay, this is series, one after the other. If I change the arrangement and now they are connected like this, alright, like this, like this. Now these are in parallel, alright. Here the resistance offered to the electrons will be less, here there will be more, and also here, like I'll tell you something for numerical purposes. Suppose this had a resistance of 1, this had a resistance of 1, this also had a resistance of 1. The total resistance will be 3. Over here, if this was 1 or supposedly 2, this was also 2, this was also 2. The collective would be less. The collective would be added like this, 1 upon 2 plus 1 upon 2 plus 1 upon 2. We put the resistance in the denominator. Then we obtain it. Supposedly this was 3 by 2. Now I reverse it, 2 by 3. This is my actual resistance. This is a class 10th level question. You need not go into the detail, but this is a good question. Alright. So resistance is maximum in series, minimum in parallel. Okay, parallel. So the total resistance is the sum of individual resistances in a series. Yes. We add each of these. Voltage across each component is the same? No. Current is divided? No, it's same current flowing. Components share the same path? Yeah. This is also correct. Which of the following is a characteristic of a parallel circuit? Total resistance is sum of individuals? No. It's the sum of reciprocals. Reciprocals means inverse. Voltage across each component is the same? Yes, it is same in this. Current is divided among the components? All components share the same path? No. No. Which of the following devices converts mechanical energy into electrical energy? Mechanical to electrical, generator or even a dynamo. Alright. Yeah, both are correct. You can add and dynamo. So that will be all for today. Thank you.